Q6602-1. The combination of lift and centrifugal force produces A. Coning, B. Flapping, C. Coriolis effect. The correct answer is A. The combination of lift and centrifugal force produces a phenomenon known as coning. Coning refers to the upward bending or flexing of the rotor blades at their tips during helicopter rotation. It occurs as a result of the combined forces acting on the rotor blades. When the rotor is spinning, the centrifugal force pulls the blades outward, away from the rotor hub. At the same time, the lift force generated by the blades opposes this outward movement and tries to bend the blades upward. The interaction between lift and centrifugal force creates a balance where the blades are forced upward and outward, resulting in the characteristic cone-like shape of the rotor disc. This coning action allows the rotor blades to maintain an effective angle of attack and generate lift throughout their length, even at high rotational speeds. The combination of lift and centrifugal force produces coning of the rotor blades. 6602-2. With the rotor turning at normal operating RPM, blades will bend upward due to A. Lift being greater than centrifugal force, B. Centrifugal force being greater than lift, C. Lift being greater than drag. The correct answer is A. With the rotor turning at normal operating RPM, the blades of a helicopter will bend upward due to the lift force being greater than the centrifugal force. The lift force is generated by the airflow over the rotor blades as they rotate. This lift force acts perpendicular to the rotor disc and is responsible for supporting the weight of the helicopter. The centrifugal force, on the other hand, is the outward force that results from the rotation of the blades. In order to maintain a balanced condition, the lift force needs to be greater than the centrifugal force. This causes the blades to bend upward, opposing the outward pull of the centrifugal force. The upward bending of the blades is commonly referred to as blade coning and allows for the efficient generation of lift throughout the rotor disc. With the rotor turning at normal operating RPM, the blades will bend upward due to the lift force being greater than the centrifugal force. 6603-1. What will cause an increase in coning? A. Increase in lift, increase in centrifugal force. B. Increase in lift, decrease in centrifugal force. C. Decrease in lift, decrease in centrifugal force. The correct answer is B. An increase in coning of the rotor blades is caused by an increase in lift combined with a decrease in centrifugal force. When the lift force acting on the rotor blades increases, it creates an upward force that tends to bend the blades upward, causing them to cone. This increase in lift can be a result of an increase in collective pitch or an increase in the angle of attack of the blades. On the other hand, the centrifugal force acting on the blades is a result of their rotation and tends to pull the blades outward. If the centrifugal force decreases, it reduces the outward pull on the blades, allowing them to bend upward more easily. Therefore, an increase in coning occurs when there is an increase in lift, upward force, combined with a decrease in centrifugal force, outward force. An increase in coning is caused by an increase in lift and a decrease in centrifugal force. 6608-1. The purpose of lead lag, drag, hinges on a three-bladed, fully articulated rotor system is to compensate for A. Coriolis effect, B. Dissymmetry of lift, C. Blade flapping tendency. The correct answer is A. The purpose of lead lag, drag, hinges on a three-bladed, fully articulated rotor system is to compensate for the Coriolis effect. The Coriolis effect is a phenomenon that occurs when a rotating object experiences a force perpendicular to its motion. In the case of a helicopter rotor system, the rotating blades experience a Coriolis force due to their rotation and the movement of the aircraft. The Coriolis effect causes the blades to experience an apparent change in their path of motion, resulting in a lead lag motion. This means that the blades can move forward, lead, or backward, lag, in relation to their normal plane of rotation. To compensate for the lead-lag motion caused by the Coriolis effect, lead-lag, drag, hinges are used in the rotor system. These hinges allow the blades to move forward or backward independently of each other, effectively accommodating the lead-lag motion and maintaining the integrity of the rotor system. The purpose of lead-lag hinges is to compensate for the Coriolis effect, which is the primary factor causing the lead-lag motion of the rotor blades. 6608-2. Coriolis effect causes rotor blades to A. Vary the angle of attack. B. Accelerate and decelerate. C. Press S 90 degrees south in the direction of rotation. The correct answer is B. The Coriolis effect causes rotor blades to accelerate and decelerate. The Coriolis effect is a phenomenon that occurs when a rotating object, such as the rotor blades of a helicopter, experiences an apparent force due to its rotation in a non-inertial reference frame. In the case of rotor blades, the Coriolis effect manifests as an acceleration and deceleration of the blades during their rotation. As the rotor blades rotate, different parts of the blade experience different velocities due to their angular motion. This variation in velocities creates a Coriolis force that acts on the blades, causing them to accelerate and decelerate as they move through their rotation. The Coriolis effect causes the rotor blades to accelerate and decelerate. This effect is significant in helicopters with fully articulated rotor systems, where the blades can move independently and experience varying velocities during rotation.